Does that make sense? All right, this is problem solving. Like, it's things like that. If I can just get that point, I can get this thing solved. And we knew it involved calculus with derivatives and slope. Slope of a straight line equals slope of a curve. By the way, that's a great problem solving skill. So, Josephine, I have to give a good bonus problem where the key strategy is you're going to say, all right, slope of a straight line must be equal to the derivative of that crazy equation, right? But what makes it crazy, you get down to something like this and everyone gets confused. Take your eyes, look back to see if you can substitute something. You follow me? That's what you do. You go, wait, can I substitute something? This is a system of equations where I can take this equation and this equation. But it was neat. I was watching their faces. Kel and a couple others go, wait, you're getting the same equation as before. It almost looked like it, didn't it? That does throw you off. You think you went in a circle. It makes the student frustrated. It was a tad off. This had an extra what on it? Thanks. You know, a great job with that. And thanks for being patient.
I was trying to do what is Pythagoras.
Were you close to this?
No, what I did was I took the whole thing as 8, like -5 unit, and that unit as 8. Then I was kind of lost. I was doing the derivative. I'm like, okay, I just need to do the mid-value theorem, and I kind of got lost. I was thinking differently.
Would you remind me before you leave today? I'm going to give you another one that looks like this, something like this. If you find this stuff fun,
okay.
If you know what I mean, I'll give you one. Give me another one where it's like you got to kind of do what? Derivative, slope of straight line, substitute. Cool. All right. Hey, in your notes, would you put section 3.6? You know what this is titled?
Logarithmic, right?
Yep.
I have a question. Is this going to be on the test?
Oh, that last one?
Yeah.
No.
Yeah, sure.
So, that's a good one, isn't it? Tell you what, I won't put it on there, but maybe I'll give you a good bonus like that.
Okay.
So that gives you like incentive to what? Kind of know what happens, so maybe you could try the what? Bonus. What were the key moves in that problem? Key moves was slope a straight line, or here's a key move, just guess, 1 and 2. Remember the answer was 2? Hey, but slope a straight line equaled derivative of curve, but then we had a mixture of x's and y's. We were frustrated. The second key strategy was substitution. Take something to substitute so you get all the equation in one variable. Then you rock, then you're rolling. Then you're moving. It's kind of cool, right? Yeah. I'll give you one thing. Remind me, Sarat in the class, give you one kind of practice like that.
Okay.
All right, when this is 3.6, what's this on? Derivatives of?
Logarithmic function.
Logarithms. So I'll just put logarithms and then I'm just put in parentheses, derivatives, logarithms, derivatives, or the author wrote derivatives of logarithmic functions. So, let me go over here. What was the derivative of x?
E to the power x.
Well, we've discussed this before. Everyone, what's the derivative of ln of x? Does anybody remember?
1 over x.
And don't worry if you forgot it, but we've done it like, I don't know, 2 times, but I never mathematically proved it, and I said I would promise you I would prove it. If you know where a derivative comes from, it makes it easy to remember that. No luck. Maybe you hate math proof, but if you know where a derivative comes from, it helps you remember. This derivative is 1 over x. Okay? Cool? So, oh, why? So let me start out. Now when you go look at that and brainstorm, how the heck did we do that? make sure I do it right when I'm jotting some notes on the board. Does anyone have that up there? Now, what's the derivative of y to the ln of x?
1 of it.
1 over x, true? I'd like to just take a moment and show you why. Like, why is this the case? Prove it, true? So what we're going to do is you go, well, I don't know how to do this yet. So we're going to do something at the beginning of this problem. How about we e both sides?
Okay.
We can do that balanced equation, right? So I'd like you to put e to the y here, and then over here you have to write what? E to the
ln x.
Now, does anybody in this class recall from pre-calc that e to the ln of x is very neat? It simplifies very nicely.
1.
Don't worry if you didn't know it. So close. E to the ln of blah is blah. So e to the ln of 5 is 5. E to the ln of 2 is 2. E to the ln of car is car. E to the ln of Fred is Fred. So what's e to the ln of x?
E to the
X. So did you know that? I did this because of that. I was like, oh, I could do this to both sides. This just becomes a what?
Just x.
You like it? But I know it's a strategy. You're like, I would have never thought of that, but this is the math proof. But what's still on the left side, though? That got weirder.
E to the y.
But do you agree? I know it's not explicit, but can't we do implicit differentiation? Do you all see this? So if I do this implicitly, I'll be able to get a derivative of dy dx, and I'll figure out what the real true derivative of ln of x is. Sound good? So here, implicit differentiation. The right side's going to be easy. Everyone, what's derivative of x? 1. But this side, remember what you got to do? Derivative e to y would be e to the y. The bells are going off because you just differentiated, Amber, something with the y in it. So I have to, right next to it, write a what? dy dx. Now, can you isolate dy dx?
Yeah. Divide a, divide.
And we're like, okay, we're done. But this looks kind of weird, doesn't it? That looks kind of weird, doesn't it? But that's our answer. So I was wondering if you can go back with your eyes and look back in all your nice work to see what was e to the y equal to earlier. And we can substitute it. Where was it? Oh, Kelly saw it. She goes, look right here, everyone. Look with your eyes. What can I substitute for e to the y?
X.
Everyone, let's put that Helmo symbol, math proof finished. Or QED. Who proved it? That's how you find the derivative? That's y. The derivative of ln of x is what?
Why'd you switch the y and the x?
You mean here?
Yeah.
Oh, I just went back to see what I could substitute for that. Because Amber, isn't that a goofy looking derivative? But can't I substitute that for that? Look, e to the y is equal to that. Isn't that cool?
Yeah.
And that's why.
Do you have to?
Well, this was our math proof. That's what I mean. This was the math proof. Amber, that's what we're saying. Like, it's kind of weird. You know, it's like, boy, I wouldn't know to do this. It's a math proof. We're proving why this is the derivative. Wasn't that cool? I know. All right, but now that we got that, can we do something like this? I want e to a u. Can't we say that the derivative is always u prime times e to the u?
Yes.
Isn't that really what goes on? Amber, you were doing it earlier. What's the derivative of e to the 4x? E to the 4x times up?
4 e.
What's e derivative of e to the 5x? Of y equal to e to the 5x?
5 e to the 5x.
That's right. So here's another way. Let's do it now with ln's. What if y equals ln of u? Then the derivative is u prime over u. Do you like that? Because of chain rule. Check it out. Watch. This is the derivative of what? Ln of x. But what if this is more complicated than an x? Then we'll have to multiply the chain, the derivative of that, which would just be the what? U prime. That'll be our g. If you don't like u, you can use g. G prime over g. That's chain rule. So can we do a few? All right, watch. I would like that derivative. The cool thing is this derivative does not have an ln in it anymore. I know. That's the cool part. What goes in the denominator?
2x plus 3.
Piece of cake, right, Ellen? But what goes on top?
2.
Come on, you gotta admit, ln derivatives are easy. Is that it? That's it. Wait, can't you? No, you can't simplify. Or sometimes they're fun. Look at this guy. You can simplify it. What if it was just ln of 5x? Watch how you really simplify that dude. I'm serious. You'll get it nice and simple. You'll make it as pretty as that guy over there. I promise you. Watch, Kelly, you'll make this guy almost as pretty as that guy over there. Because what's this say? All right. Derivative. 1 over, put my g here.
5x.
Multiply your g prime.
5.
1 over. Oh, so this is the same answer as what? Derivative on, oh, so derivative on of x is the same as ln of 5x. You all agree?
Mm-hmm.
Kel, that would be a fun math proof. Prove that ln of x is always equal to the derivative of ln of ax, where a is a constant. You could prove it. You would show it. You could show all that math. Is that what I get? All right. Let's do a weird one. I still think I can't stump you. Look. 5x squared plus 6x plus 3. I just don't think I can stump you. I just don't think I can. What is the denominator?
5x squared.
What is up here?
10x plus 6.
Done. Unless you want to factor out of 2 out of the top, but I wouldn't. These are fun though, everyone, when you do trig functions. So let's do a couple of those. What do you mean, natural log of a trig function? They're fun.
Let's do it.
All right, they're fun. These are boring, aren't they?
Yeah.
So let's do some elements of trig functions. I'll start out. Come on, trust me, it's gonna be fun. Try that guy. Because listen, people are gonna go, oh, I know a good way to write this answer.
So y prime is
So what goes in the denominator?
sin x.
Well, what goes up here? The derivative of that.
Cosine.
Okay, I'm done. But watch. Full credit. Full credit, but I was wondering if someone in this class had another way to write that answer because they know trig identity.
Secant.
Who is tangent of x is
Cotangent.
sine over cosine, so I
Cotangent.
heard it. Cotangent of x. Couldn't I write it like that?
Mm-hmm.
If you wanted to. Right, Josephine? Tangent of x is sine over cosine, so I might as well just, I can write this a little prettier. Hey, you're, okay next. Trig function, when you natural log of a trig function, they come out what? They come out nice. Let's try another one. You probably know where I'm going with this one. Cosine. Try that one. Amber, are you okay? Did you get the last one? I'll put it back up.
No, I missed it.
Oh, I'll put it back up. And when I'll put this, go ahead and try this one. Amber, I saw Amber's face. She's like, man, you erased it too fast. So, hey, Amber, what I did was, I put that down here. I multiplied that derivative up here. Derivative sine of x is. But then we decided, hey, there's a trig identity. Because
Yeah,
tangent of x is sine of x, so let's call it cotangent, right?
Yeah.
I didn't want you to freak out, look at the back of the book and go, right, Claire, like, why did they write cotangent of x? I got that. Oh, yeah, it's the same thing.
Yeah.
But try this, it should do something similar. What's the bottom?
Cosine of x.
Now be careful, derivative cosine is not sine of x. It's what?
Negative.
Negative sine of x, right? Good. Anybody got a nice way to write that? I like it. So that's right beside it there, Amber. I want to erase it. I promise. It'd be just like... ln and trig functions are fun, aren't they? Let's do one more though. I'll wait till Amber has all. Let's do another one.
Oh my god.
But on this next problem, I'm encouraging everyone in the class to really try your best. After you get your answer, scan everything, see if you can factor anything, and see if you can simplify it. Okay? Sound good? Here it is. You ready? We got these. Look, we know these. Everyone see these? Try this. ln secant. I encourage everyone, once you get your answer, to really what? So try hard and see if you can really simplify and factor and stuff. Okay? All right, what's this here?
Secant x.
What's the derivative of secant of x? Secant of x what?
Tan.
Anybody see anything?
Yeah, you can cancel out.
I love it. That's what I'm talking about. I love when you don't stop, you kind of look at it and you go, well, heck, the secants do what? Isn't that cool? So when I told you these trig, when it's natural log of these trig functions, they're kind of fun, aren't they? All right. I thought I saw one in the textbook earlier. Put it on my practice sheet. Try this one, everyone. Take your time, dude. ln of tangent of x plus secant x. Well, what goes in the denominator?
Tangent of x, secant x. So tan x is.
Here comes chain rule. We multiply the derivative of all that. So what's the derivative of tangent of x? Secant squared of x. Excellent. Plus, I'll put a plus. What's the derivative of secant of x? And I guess we're done. Well, let me step away. I just wanted you all to kind of give it the bird's eye view and say, all right, that's it, huh? Well, is there anything